In a previous video, I developed a few concepts for conditional probability. Conditional probability. I developed some concepts, and I did a fairly basic example. In this video, I like to quickly review these concepts and maybe do a fairly more complicated example. If you remember, we had a probability of A given B, where A and B were events. And we visually, with some set theory, developed its probability of A and B over the probability of B. Sometimes this is very straightforward, and this conditional probability is fairly easy to do. However, let's call that case 1. There's another case though where the flip of that is a little bit easier, meaning sometimes the probability of B given A is a little bit easier to do than the probability of A given B. And we developed this in the prior video using, again, we used the rules, and we also used some total law probability, and that all came out to be probability. Let's go back. Let's stick with probability A and B, but we're going to write it in terms of B given A. So it's going to be the probability of B given A, because we just said that's a little bit easier to play with. So probability of B given A times the probability of A all over the probability of B. This portion here, we just manipulated this using some basic rules of the conditional probability that we developed. Now let's take a look at the bottom number, and that was simply the total law probability, where the probability of B was the probability of B and A plus the probability of B and not A. And again, that's where A had two outcomes. And again, if you simplify this, which falls out to be, this piece is just the top piece because it's the probability of A and B. Then that's the probability of B given A times the probability of A plus, and then this portion here is just the probability of B given not A, not times the probability of A. So let's take these two basic ideas here. I mean, one's where you can see we know the conditional probability of A given B, whereas other times it's a little more difficult to do, so we need to find probability of B given A. So we developed this in the first video. Now let's take a look at a problem. Let's take a look at a slightly different kind of problem here. Let's suppose we have a bag with 8 dice. 8 dice, and suppose we have 8 regular dice. 8 regular dice. When I say regular, I mean the probability of a dice, probability of getting a 1, 2, 3, 4, 5, or 6. Either one of those is 1/6. So it's your regular, normal die. And the other one would be we have 2 irregular dice. Now with this one, let's suppose the dice, here we go, choose a different color. Suppose, I'll try to draw a little bit here. So there's your die, 6 sides. This is your front side here. Suppose that front side is a 1. Suppose the top of that die is also a 1. And all the other sides, the left side, the right side, the bottom, the back, suppose they're all 2's. So so the way this looks is we've got 2 1's and 4 2's. Okay, so the experiment is going to be reach into this bag. So suppose we have a bag with a bunch of dice here, 10 dice here, 10 dice. We reach in, we pull one out. We don't know which one it is. Could be the regular or irregular. And we roll it twice. So on the first time we roll it and the second time we roll it. Now the two events are going to be, event A is going to be, what's the probability of picking, well, let's say picking a regular die. And the event B is rolling. On the first roll, you roll a 1, and then on the second roll, you roll a 2. So that's the two events. And again, this order counts here. You roll a 1 and you roll a 2. So what we want to find is the probability that A, you picked the regular die, given B, that you rolled a 1 and a 2. So let's do this 2 ways. Let's do this 2 ways. Because back in our first video, we actually had 2 ways. The first way was with all these, with these conditional, with these rules for conditional probability. Now let's take a look at, first let's take a look at that, and then we're going to look at the second way, which we also developed in the first video. And that was more visualization, but we're going to hold up on that until we get finished this. So probability A given B, and if you use this formula right here, this conditional probability formula, B given A, well, you know, B given A, that says the probability of getting a 1 or 2 given it's a regular. So that's 1/6 times 1/6. And then the probability of B, the probability of drawing let's go back a little bit here. Sometimes we got to step through this, make sure we get the right sequence. This is given that we have a regular die. So what's the probability of A with getting a regular die? And that's 8 out of 10, because it's 8 out of 10. Divided by, and on the bottom, it's where we have the total law of probability. This portion here on the bottom is the same as the top. So that would be 1/6 times 1/6 times 8 out of 10 plus. Now we've got the probability of B getting a 1 or 2 given it's not regular, which means it's irregular. So that would be the probability of getting a 1 is 2/4. And the probability of getting a 2 is 4/6. I'm sorry, that's 2/6, not 2/4. It's a total of 6 possibilities, not 4. So that's 6. Times, and then the probability of getting an irregular die is 2/10. So let's simplify this a little bit. Let's suppose we multiply top and bottom by 6 squared times 10. 6 squared times 10, and then multiply this bottom by 6 squared times 10. So that gives you, on the top, gives you 8, and on the bottom, it gives you 8 plus 2 times 4 times 2, which is 16. Multiply top and bottom by 1/8, and you get 1/1 plus 2, which is equal to 1/3. third. So that's the probability of A given B using the formulas. Now let's take a look at this a little bit more. Let's keep in mind it's 1/3. So we're gonna switch over here. Now we're gonna look at this through visualization. There's a lot of ways to look at it through visualization. You can look at pictures. You can look at trees. There's a lot of different ways. Let's take a look at a tree. Let's visualize this as here's A and here's B. Now keep in mind A is a regular die, so that's 8 out of 10, and B is a irregular die, so the probability is 2 out of 10. So now then we flip the die we chose twice. So we flip it and we get a 1 or a 2, or we don't get a 1 or a 2, which means all the other combinations. You got 1 1, 1 2, 2 1, and 2 2. So the probability of getting a 1 1 is 1 over 6 times 1 over 6. And the probability of getting a 1 and a 2, given that we drew from the regular, is 8 over 10 times 1 over 36. And then this is also 8 over 10 times 35 over 36. Now here we do a 1. Flip the die. We get a 1 on the first try. Flip it. We get a 2 on the second try. So it's the probability of getting a 1. Well, the probability of getting a 1 on the first try, given that it's coming out of the irregular, that's 2/6. And then the probability of getting a 2 on the second try is a 4/6. And then this is 1, 2, not. So this is 1 minus, and what that is, that's 2/9. So what do we have left? We have, this is 2/9 times 2/10. I just simplified 2 times 4 over 36 to be 2 over 9. And then this is equal to 7/9 times 2/10, 1/5. So now we're going to use some basic probability to finish this off. We know what we want. We want the probability of A given B. So we use basic probability. Basic probability. We have the desired outcomes up top. Desired divided by total. So what are the ones that we're restricted to? Well, we are only looking at, it's got to be a 1. Let's do a different color there. Let's do black. This here and this here. So that's equal to 8 over 10, which is 4 over 5. 4/5 times 1 over 36. Over 4/5 times 1 over 36, because I'm adding these two now for the total, plus 2/9 times 2 over 10, that's 1/5. So now let's simplify this a little bit. We multiply top and bottom by 5. 5's go. Now we multiply the top and bottom by a 4th. That goes, that's 2 over 4. So that makes it a 2 on the bottom. Now let's multiply the top and bottom by 36. That goes